Data Lunch and Learn. Today we have the fine folks from Tabsdata joining us. We're going to be talking about PubSub for tables. It's actually pretty cool. I checked out the product and I think it's why I decided to invite them onto the Lunch and Learn so you guys can check it out too. With that, I'll let both of you, Arvind and Alejandro, take it away from here. So,
thank you, Joe. Hi, everyone. It's a pleasure being part of the practical data engineering community. I live under a rock, so I didn't even know there's such a vibrant community out there. So really appreciate you guys having us on board, and happy to share what we've been working on for the past year plus. So let me share my screen. Hopefully you all can see my presentation. Okay. Perfect. So Alejandro and I, Alejandro also goes by a short nickname of Tucu because he's from Tucumán in Argentina, where he is right now. As we're participating in this lunch and learn. So Tucu and I actually go way back when, almost like nearly 30 years working together. I stopped at saying 25 plus because I don't want to further age both of us. But the fact of the matter is we have been in the infrastructure world, data infrastructure world, server infrastructure world for a while. Me particularly, for the past 20 years, I've focused on data integration, and Tuku has been, pretty much the accomplice and crimes that we did in the previous company, and now we're here. So with Tabsdata. So without further ado, let me just go into the crux of it. The goal is for me to set up an overview of what Tabsdata is and what it is not, and then I'll hand it off to Tuku for doing a demo. And in the meantime, please feel free to ask questions. If there's anything that doesn't make sense, jump in. Happy to take your questions as we're going along. Or if we get done, ahead of time, we will use the last minutes, whatever is left off, for the questions. So what is PubSub for tables? What is Tabsdata? And the best way to understand this is if you think about how data infrastructures work today, how the pipelines work today. When you talk about, from a data engineering perspective, the data that needs to be gathered from data producers and made it available to data consumers has to go through a series of engineering steps. And these are what we loosely define as pipelines. There could be ingestion, there could be preparation, transformation, cleaning, quality, and what have you, all the way up to modeling. After which, once that data is it kind of passes the acceptance criteria, it then becomes published and available through catalogs and secure repositories and such, and that's where the data consumers go and work. And this has been the way things have evolved over a period of time. We want to change that equation for a very good set of reasons, not just one, many reasons actually, and that's kind of built upon our background and our experiences, in the space, which is if you think about the producers and consumers as two separate extremities within the enterprise that need to communicate with each other through data. What Tabsdata allows the data producers to do is publish their data as tables. So whatever systems they're coming from, whether they're coming from databases or flat files or SaaS applications, etc., Tabsdata allows those data producers or somebody acting on the behalf of the data producers to publish those data sets as tables. These tables then become an abstraction for the sources themselves. Once these tables are in Tabsdata, you don't need to go back to the source system. Every single time there's a refresh, the publisher would run again and then create that data set as a fresh version of that table. The reason why you see like a sellout of tables in the background is because these tables are immutable, and every time a publisher runs, it creates a new version of the table. And what you see, these blue boxes, these are boundaries for security, implementation, and column collections. More on that, through the demo. But once the data is published, the data teams can go in and then create conforming representations, standardize the data models that have to be overlaid, make sure that they are speaking all the right language, make sure that between sales and finance, customers are being represented as customer ID and not org ID or account ID or some other dialect of that. And moreover, they can do aggregates and joins and transforms and productize and package and redact, do all fancy things that they need to do to create subsequent data sets, that are then ready for consumption. Once they're ready for consumption, they can be subscribed to by the data consumers. And those data consumers could be data platforms. They could be, reverse ETL systems, operational systems that need curated, joined, or, productized data in order for it to work properly. So that is, at the highest level, what Tabsdata is. Now, if you take a closer look, what Tabsdata is effectively allowing you to do is to use the pub/sub semantic to decouple the communication lines between the data producers and consumers, also providing a safe space for the data teams to go do a whole bunch of engineering activities on top of those data sets to make it usable and viable for downstream consumption. One of the direct consequences of this is the transparency and the traceability that this brings in by default. Your data lineage is what the data flow is. Every single time a data set is deposited to a consumer, it comes with itself, it brings with itself the full lineage graph of exactly where the data came from. The system underneath the covers has the capability, is actually capturing metadata for full-blown provenance. We don't have, the provenance, explicitly available through the UI just yet. We're working on it in the future release. The provenance will be available so that you could trace back every tuple, every record, from one system all the way back to where it came from. So lineage is clearly visible. Now, the other thing that comes as part of this pub/sub decoupled architecture is there is no explicit orchestration that you need to do. When you register interest as a subscriber or as a transformer into a table within Tabsdata, and that table refreshes, your subscriber, your transformer will automatically get executed. You don't have to manage the conditional execution across, like a big empirical piece of code written in Python or XML or what have you. And consequently, it becomes a lot easier because you're not making any implicit assumptions. You're not making, expecting any state specific details outside of what those tables represent. So this is turning data flows traditionally, which have been very empirically, bound, very logic bound across different systems, and consequently making them harder to maintain and debug, to declarative systems that are basically, if I were to create this flow, you can come in and look at what exactly I've done, and you would not be second guessing anything because everything will be in the black and white. And that idea of having declarative data movement is very powerful in terms of creating complex flows across the enterprise. And then last but not the least, once you have multiple of these producers and consumers participating in exchange of data across the system, it's all in one place. It's visible for your inspection, for your traceability. If there is a data issue, a logical data issue that you want to get to the bottom of, the system will allow you to do that, in the fastest way possible. So that's, just a closer look. So when should you use Tabsdata? The obvious, aspect here that we serve is data integration, which kind of at a highest level breaks down into data ingestion, data preparation, and data delivery. So you could do that, through Tabsdata. You could implement your ingestion and preparation logic. All this logic is implemented using basic Python functions, and you're welcome to use your library of choice, your tools of choice in your Python environment. And Tabsdata will create the sandboxes to run it for you. You can implement quality checks if you're using, some libraries and tools and utilities for implementing data quality checks. You can do them as part of identity transforms. And if you have some domain-specific processes that are not quite easy to express in traditional pipelines and systems, this gives you better flexibility in order how to implement those. You effectively can use Tabsdata instead of pipelining systems like Airflow or ingestion systems like Fivetran, et cetera, because it combines that capability and gives you access to deposited data. What you should not be using Tabsdata for is messaging or event streaming, or on one hand, it's not a substitute for a system like Kafka or IoT hubs. But on the other hand, it's also not a substitute for databases or data lakes. even though we have versions of these tables available, we're not optimized for transactional workload, where you're updating a few rows here and there. We're not optimized for OLAP, kind of querying and analytics. Those systems, are those functionalities are better provided by systems like, your relational databases or your data lakes or data warehouses. So we're not a substitute for either databases or data platforms or messaging, message brokers like Kafka and so on and so forth. And then what are the typical use cases? There are 4 that we highlight typically. That we have people who have used Tabsdata in different ways than these 4, but your imagination should carry you wherever you want to use Tabsdata, and we're happily support it because we don't think data movement should be that complicated as it is, ended up being over a period of time. So the first use case we talk about is the instant ETL. And this kind of goes back to the graph, the unified view that I showed you a few slides back. If one of the publisher runs, Tabsdata automatically calculates the entire dependency graph from that publisher to figure out what needs to be updated. And it doesn't have to be a publisher run. It could be a time-based trigger for one of the transformers, a transformer that is running, every night. The moment that transformer runs and it updates a state of a table downstream, anything that is dependent, from that table will automatically execute. So the moment you have one data set updated anywhere in the system, anything that depends upon it will automatically get updated. This is the equivalent of like a streaming without streaming. It's an instant ETL without having to worry about windowing function and rolling windows, sliding windows, and such. Because as I'm sure a lot of you know, maybe all of you know, going from batch-oriented data management and data manipulation to stream-oriented is not a one-to-one mapping. It changes the semantic. It creates a lot of complexity. You have to have a protocol of engagement between the producers and the consumers, and it's just not worth it from my perspective. Unless you have a specific streaming use case, please don't use streaming for data integration. Batches, micro batches, they're all fine, but then the problem with batch systems is, typically I hear things like, hey, we have to wait for this dashboard to update in the night, because that's when all the pipelines are run. So you don't have to do that anymore. And because these systems automatically decouple the sources, and give you that abstraction of those data sets available within Tabsdata, you're not putting any extra load on these systems and on the source systems or the destination system. So this instant ETL becomes, pretty much the de facto way by which Tabsdata is used in most places. The truth in data is visible because every single update that you see can be traced back to its origins. Whether it's a one-hop origin that is straight up, back to your source system, in which case it will give you information as to when was that publisher run, what time, and what was the raw data that was captured out of it. Or it could be, a 255 table graph, which of course I don't want anybody to have 255 table graph, but the fact of the matter is, if you have that complicated systems, you would be rest assured that you'd have full traceability all the way back to the origins. On me. We talked about briefly how maintenance management operations becomes a lot easier when you're dealing with a declarative system. But declarative systems are a key to enabling data operations practices, the data ops practices. If you want to have the ability to constantly iterate and keep an eye on how your infrastructure is evolving and how you can keep up with changing business requirements, and you want to go full-blown data ops discipline, we believe the declarative piece will allow you to scale significantly faster and better and easier than any other systems out there that will give you the data ingestion and preparation capabilities. And then finally, this is something that catches most people by surprise. If you go back, 2 decades and start looking at how the legacy ETL systems worked, they worked with structure-to-structure transformations. So I worked at Informatica. I worked on, rewriting Informatica for those 9.0 and above platform versions. I can tell you, Informatica mappings are mappings that take, a source, which is a structured table, and map it to, an output, which is a structure table. And then in between those structure tables, you can do joins, you can do transformations, you can do, lookups, and so on and so forth. The problem with most enterprises today that have significantly invested in the ETL infrastructure of that era is that they cannot break free from it easily because there is no direct mapping between those systems and the modern systems, which are basically pipelining systems that split the different aspects from the ETL process into different services. So you have an ingestion service, you have a preparation service, you have a cleaning service, you have a normalization service and such. So these tools and systems, they organize themselves as layers that you layer on one on top of the other to create a pipeline-like flow. So consequently, if you're a large bank who has thousands of Informatica mappings, it's going to be a very daunting task to think about the rewriting of that logic all the way to this new modern stack. So, and as a result, they find themselves in this weird position. Now, Tabsdata is the only modern data propagation solution that gives you that structure-to-structure mapping. And it does so in a relatively open, very easy to use and open way that allows you to take advantage of the innovations that the modern data stack is bringing in without having to worry about the legacy infrastructure and maintaining it and managing it, forever for the rest of your life. So that's what we mean by the legacy ETL modernization. There are not many alternatives out there which will not require a full rewrite. Tabsdata actually is probably the only system out there that can directly map the logic from your talent data mapping or your Informatica mappings straight into your publisher transformers and subscribers. And then finally, here's a look at the architecture. I will not belabor this. Hopefully, through the demo, a lot of these things will become clear. Tabsdata is a server infrastructure. It's a very lightweight, low-footprint server infrastructure implemented in Rust. You can install it on your laptop. You can install it on a VM on bare metal, or this part is not yet released to the public, but we have the ability to deploy it on Kubernetes, on kube clusters, etc. The parallelism that Tabsdata has is based on ephemeral worker threads, worker processes rather, that can get spawned and get attached to cores that you may be running the system on. In case of kube cluster, it'll be the nodes, but each of these worker processes participates in a complex DAG transaction, that completes or succeeds together or fails together. And that way we can ensure that the consistency or the pristine state of information is maintained throughout your deployment. The one big question that I get a lot is, hey, you seem to be storing data over and over again, different versions, so you must run out of space very quickly, and that is true. But you can lifecycle manage the data out of it. You can set up space limits to your collection, saying and that space limit could be time-based or size-based. So you could say, I only want to keep the last week's data or last month's data, or I only want to keep data that adds up to 2 terabytes for this collection and 10 terabytes for that collection, etc. And then finally, in all of this, your interface to Tabsdata is Python, and hopefully you'll be able to take a look at what it feels like to be developing the publishers, transformers, and subscribers and deploying it on Tabsdata. So with that, I will stop sharing my screen and hand it to Tuku, who will walk us through the functioning of Tabsdata. Tuku, you're mute.
Yes, I'm fighting with Google Chrome. Thank you, Arvin. Hi, everybody. So I will try to show off a little bit what Arvin described, kind of like things in action in Tabsdata. So to that, first, let me start with some concepts. As I'm working through the concepts, I'm going to start doing some parts of the demo, and then after that, based on any questions that you may have, we can dive into different technical aspects of how things work. So Tabsdata, as Arvin was saying, is a server system that is organized in collections, and each collection has tables and then has publishers and functions that we call publishers, subscribers, and transformers. Collections are very similar to what you would say in a MySQL database, a MySQL Server a database, or in Oracle a schema, right? So whenever you go to a collection, then you will have the tables. Like I go, for example, here I have these. Sorry, I want to go to airports and wrong place. So I have a list of tables, and then I go to see a table, and it's very similar to what you would see in a SQL database, that you have a schema of the table, and then you can also query, so you can see the data that is on the table. A big difference from SQL databases is that whenever you define a table, you don't have to worry about defining the schema of the table. You just define the name of the table. The first time, for example, here I have a table called charter that it never got any data into it. So we don't have a schema. So as soon as we get data into this table, whatever the data comes, the schema is going to be inferred, and this schema can go changing over time. And you will see how that schema is changing over time, because we keep all the history. Besides tables, we have the publishers, subscribers, and transformers. These are small Python functions that they tell you how to get data into Tabsdata. For example, if I go to an airport publisher, here we have some information about the publisher, but let's go to the code itself. So, okay, so this is kind of like a bit on the complex side. That what it's doing is connecting to a MySQL database, and then is getting data from all these tables, and then in a single operation is getting data into all these tables into Tabsdata. So what you are seeing here is a Python decorator where you give the information about your MySQL database. Of course, credentials can be put in a secret store like HashiCorp, for example, and then you specify in which tables in Tabsdata you want to store the data. The function is the function that you have to write just receives the tables that come from the MySQL and then outputs them, so they go into the Tabsdata tables. Normally it's a pass-through function and identity function. Going to a simpler one. For example, this is actually simpler, but it has another twist. In this particular publisher, we are again querying the same MySQL database, but we are just doing a single query on the booking table, but with the caveat that we are doing a work clause where we are using a booking ID to retrieve information greater than that booking ID. We're just doing here, for the purpose of the demo, like a small artifact to limit every ingestion to 10,000 records. So if I run this function multiple times, every time it's going to ingest 10,000 records, and then by doing that, we are simulating incremental data that is showing up in the MySQL database, and we're getting into Tabsdata. In this case, what we are just doing, like some small logic to be able to keep track of the last booking ID of the data that we capture. So the next time that this function runs starts from that offset onwards. Right. So these are tables, and I mentioned that you don't have to define schemas. I mentioned the publishers. You have similar to publishers, you have subscribers. While publishers bring data from external systems into Tabsdata, the subscribers subscribe data from Tabsdata to external systems. In this case, I'm having a subscriber that is getting data from the booking table in Tabsdata within the airport collection. We are getting that into a Snowflake table, right? And here we're saying that we want to replace all existing data into the Snowflake table. If I here have another very similar subscriber that looks a little bit more complicated. What I'm doing here, I'm uploading the data to S3, and then after that, I'm registering that data in AWS Glue as a iceberg table, and as an iceberg table. And in this case, I'm telling I'm telling Glue that I'm updating the data in Azure. I don't want to replace. We're going to see that in a little bit more detail. Why is different the Snowflake and the Iceberg table, and that's are because of limitations of these two external systems, right? So we have the publisher, we have the subscriber, so we can get data in and we can get data out of Tabsdata. But then we have also we have transformers. Transformers are functions that what they do is they consume data from a table in Tabsdata and they write that data into another table into Tabsdata. In this particular case, I have a transformer that is getting the passenger and booking tables, and what I'm doing is I'm doing a join to find the passengers that are travelers in the bookings that are arriving, right? So I'm just doing like this. You could think that this is a very simple SQL join, and I'm joining the two tables, passengers and bookings, on the passenger ID column, and I'm selecting these particular columns. If you are familiar with Pandas data frames or Polar's data frames, the way that you operate the data within the transformers is very similar. And actually, we are under the hood, we are using Polars to process the data. We are using Polars because Polars has a capability to process the data in streaming mode. That means that we can process large amount of data without filling up the memory of the system. Right? So now, another thing that we can go and start seeing now is when I go and I see a table, I see the schema that I have the table, I can see some sample of the data, I can do some basic queries in here. Like, so there is like a small SQL engine in there that allows me to query the data that I have in the tables. But then here I have all the versions of the tables that have been loaded into the system. So this was the first version. This was the second version, and so on. So that means that at any point in time, you can see through the UI, you can access any of the versions of of a particular table, but you can also use queries to process any of those versions, or if you are interested, you can do a query that goes across those versions. So instead, working in 2 dimensions, that would be columns and rows, you can do a query in 3 dimensions across time. But that's something that is not that common in many systems. And so besides that, yes, Arvin mentioned that each one of the tables, once we write the table is immutable. So I cannot modify this version. If I write data again, it's going to be a new version of the table. And you can have different strategies. You can write a table like every time that you write it, you can rewrite the full table, you can append data to a table, or you can update data in the table. But the end result is a new version that is a full snapshot of the data of the table. Right? So what else? Okay, so another thing that is that is useful to see here is that for example, this is one of the first times I run a function. I run the booking publishing publisher that here, if I click in here, I can go and I see what's the code that I wrote. And you can see here that this is this is the version of the publisher that I run. In this case, I modify the publisher multiple times. The code, in this case, you don't see, here you see a difference in code because I put some stuff, right? So, but whenever you see in the graph, you can go exactly to the code that was executed in that particular run. And also, if you go to the table, you can go and see also the exact data of the table that was produced by that execution and the schema that it had. Right? So now if I go to a second execution of the same publisher, okay, nothing changed in the system, right? So I have like, it's a very similar run, but if I go to the data, now I'm seeing the second version of the data that was produced. If I go to a later execution, now things are getting more complex. In this case, yes, again, I run the publisher, right? But then I imported the booking data, but at that point there was already a transformer in the system that was consuming data from that booking, and then that produced a new table called travelers, right? So if I go to this traveler table, what we are doing is we are just identifying the bookings and passengers, and then all the travelers for that for those particular bookings. Right? So, and then if I go to a later execution of the booking table, I can see that more things are getting executed. Now, what happened here is that the difference between among all these executions is like the booking function didn't change. The traveler function didn't change either, but more things keep being added to the graph. What happened is that different developers, maybe in a team or in different teams, they kept adding transformers or subscribers that consume data from these tables. So Tabsdata automatically figures out which functions have to be executed in order based on the tables that these functions consume and that they produce, and executes them in order and in a transactional way. So by doing that, you are having always a consistent view of all the data in the system, right? And you will see the data just before the execution or after the execution, right? So in here, another thing that is, trying to explain a little bit this graph, you have the blue, the blue function is the function that was explicitly triggered, in this case, manual trigger, but it could be kind of like a frequency trigger based on a cron tab mask. It produces a new version of the booking table, right? And then this booking table is consumed by the travelers finder transformer that is consuming, besides information from the booking table, is consuming data from the passenger table. So one thing that is important to mention here is that if I go and I see, like, for example, this is the travelers finder transformer, here we're saying that it has two dependencies: the passenger table and the booking table. So that means that it's consuming data from those two tables. And it has one trigger, the booking table. So by saying trigger, we are saying that every time that the booking table has a new version, a snapshot, we want to execute this transformer, and this transformer is going to consume the passenger data from the passenger table and from the booking table, and it's going to produce a new table, the travelers table, right? So, and this is the only thing that you have to specify in a transformer. What are its dependencies? When do you want to trigger it, and what it produces out? Then Tabsdata on its own is going to wire and execute things similar to how it shows in this graph. Before I continue, any questions that you may have, any doubts? Okay, so let's move on in here. So what I'm going to be doing now is I'm going to run a part of the query, in which what I'm going to do first is I'm going to alter a table in the SQL data I'm going to alter a table in the SQL database, right? So I'm sorry, no, that's not the alter. That's So here I added an additional column in the booking table, airline. So now if we go, I pre-populated data before, so I have in Athena that is querying AWS Glue. I have this particular the all bookings table that is showing me that I have something like 71,000 records. And then if I do a query in here, I can see I have the booking ID, flight ID, seat, passenger, and price. So I just modify and I added a new column to the booking table. And then what I'm going to be doing now is I'm going to log in from the terminal, and then I'm going to run the booking publisher, right? So that in this case, the booking publisher is now running. So I go to the execution plans, and I can see that this guy is running. So it's running a very similar graph that we've seen before. And whenever this now it's taking a little while because it's writing the data. Okay, now it's finished. It's writing the data both to so through all that graph and then to AWS to S3 in AWS and registering that in AWS Glue, and then it's writing that to Snowflake. So if we go now to AWS and then we do a query in Athena, now we're going to see that we have now an additional column in here, travel agency. So somebody modified the schema in this in one of the systems that we subscribe, we publish data from, and then said Tabsdata figured that out that okay, there is a new column, and then in the way that the transformers and the subscribers were written, we were able to propagate that table without breaking anything all the way to the external system, in this case Amazon Athena. In the case of Snowflake, also very similarly, it's here we don't have it actually. Okay, so I think I did something wrong, but we don't have it because Snowflake doesn't allow to have like an automatic schema change. We have to do like a way to alter that table. That there is a trick that we can do from Tabsdata to do so. Right. So, but now if we go back to Tabsdata and then we go, for example, to the airport and we go and we see the booking table, we're going to see that the last version of the table, it has in the schema, has the travel agency column, right? And we have, okay, travel agency airlines, that is the default value because I did a simple alter table. But if I go to a previous version, I don't have the travel agency column. So that means that from Tabsdata, you can exactly find out when a data drift happened, and then you can identify so you can identify from where it came and when it happened, right? So, and then you can, if we go to the particular execution from here, so we can, okay, so this particular change happened in this graph. And then here we can see all the tables that were affected by that, and we can follow that particular change. So we can have by doing that, we can identify exactly when a change happened and why it happened. Not only Tabsdata keeps track of the data, but also it keeps track of the functions that executed the code. So if here I click in here, I can see, okay, this particular function was executed with this particular version. So it can be seen as a source control repository, not for data, not only for data or not only for the functions, but for the combinations of both. And by doing that, you know when something happened and why and when that has been changed. So by kind of like that's kind of like the demo that I have. And now if anybody has questions, I will be happy to explain a bit more like how things work, what kind of things you can do. And if not, I can explain a few more technical details of Tabsdata. All right, so Tabsdata, as Arvin mentioned, we can run it. In this case, I'm running that on my laptop, and we can run it on on a single server, or you can run it in a Kubernetes cluster. So that gives us kind of like horizontal scalability for processing. For storing data, Tabsdata, it can use like a local storage, like a file system, or it can use cloud storage. You can configure different locations, either AWS, Azure, or Google Cloud, where to store the data. So that means that gives you the scalability to store like large amount of data. And as Arvin mentioned, you can define purging logics by time or by capacity.
Tuku, is the preview for Tabby something we can touch on?
Yes, I have it here as cannot be missed. I can, as you cannot not have it, you can have so we have like an agent that allows you to query information at the moment, allows you to query information in Tabsdata. For example, show me the available collections. So, or show me tables in sports collection. So you can use Tabby to show me the schema of the contacts table. So, so you can use Tabby to query these collections, metadata, values on the tables, but also so there are other aspects that make the personally thing that makes Tabby more interesting is that so what we are building is the capability to be able to create to help us create publisher functions or subscriber functions so developers or users of Tabsdata can easily have kind of like the skeleton or is a basic subscriber or publisher that will allow you to export data out of Tabsdata or to import data into Tabsdata without having to write any code. Just Tabby will do that for you, and then you have just to provide the credentials, and then those functions will work correctly. The other thing is that we are doing with Tabby is that you are going to be able to run that from your favorite IDE. For example, a PyCharm or Visual Studio, from where you not only is going to help you to write those publishers and subscriber functions, but also is going to help you to query the external systems. For example, in a SQL database, you are going to be able to query and see what's the scheme of tables that you want to read from or you want to write from. Right, so that means that you will not have to do any context switching from your IDE into the external systems to be able to import to export data.
So just to add one more comment on what Tuku said. The reason, of course, everything needs to have AI these days, so there's that. But more importantly, we do feel that in enterprises, different domains, different lines of businesses, they have different levels of data literacy. And in an effort to reduce the amount of data requests that typically come for your data teams in the enterprise, we feel that Tabby could play a significant role in helping lower some of the basic requests that might come to the data team, so that they can be self-served to the extent possible, regardless of the data literacy across the domains and the functions. That's the true reasoning and motivation behind that AI assistant.
You'd mentioned that Tabsdata can be used for migrations. Is that right? From kind of legacy?
Yeah.
Would Tabby play a role in helping assist that as well? Is that kind of what you're leaning towards?
Yes, absolutely. So down the road, and this goes into some details of like which system it is and how that system is translating over. But we do feel that if you are, say, Power Center 10.5, and you've written 1,000 mappings, if you were to do a few of those mappings migration using Tabsdata, we could then leverage Tabby to train it to produce automatic migration from there. So, but the Tabby itself is a preview at the moment. So we have to iron out a lot of things. It's not quite production ready yet. It is getting there, but that is our eventual goal.
Cool.
Yep. All right. So time check. We have 5 more minutes, unless there are any other questions. So
It's an open source.
Yeah, I have a few questions. I was just looking at your source connectors. Like right now, there's not a ton, obviously, kind of where you're at. Like, what is your plan to expand in that space? Because, for example, like typically I might be ingesting from, hundreds of different REST endpoints in the near future, I'd imagine.
Yeah.
What's the plan to support that?
Yeah, so the connectors themselves are written in Python, and there's a plugin API that you can extend and implement your connectors. We intend to add as many connectors as our customers need. So we obviously are starting with the most widely deployed endpoints as the key connectors, but getting connectors out for us is fairly straightforward, and we can add them very quickly.
Okay, yeah, that makes sense. So like tabs, like I've seen your Rust and Polar's backend component in orchestration that you're doing here. So like what you're showing like local here, is it executing on your local machine, or is it like executing like in the cloud right now, your code?
Right now it's executing your local machine.
Okay, cool.
Right, but you could swap the execution engine to use a Kubernetes cluster.
Yeah, that's what I thought I heard. Okay.
And then the part that we did not touch upon is there's an extensive role-based access control that gets applied. So all the collections have permissions that you can give to people through role mappings, as well as write permissions and read permissions on the specific collections to collection kind of pathways. So this allows you to very carefully lay out and create a plan of who's allowed to access what. So just as an example, and I would not go into too many details, but just as a simple example, when somebody is publishing all their tables to a collection, by default, those tables will be private. And that kind of follows the Python convention of using underscores ahead of the table names. And they will be like preceded by underscore, and they will not be visible outside that collection. In order for something to be visible outside the collection, you have to first change the name, make it publicly accessible, and then give permission to another collection to be able to read from this collection. And then on top of that, you have to give permission to the user who has access to those collections, or one of those collections and such. So it's not something to gloss over, but there is a very sophisticated role-based access control implementation in there to safeguard data from falling in the wrong hands. I think Joe is getting ready to drop off, so from my perspective, and Tuku, let me know. But I believe we're done with showcasing the product. I'm Arvind at tabsdata.com. Tuku is Tuku at tabsdata.com. Please reach out to us with any questions. We're happy to see what we can do to help you get a good experience out of Tabsdata.
Thanks so much, guys. This is wonderful. So thanks to people who showed up and checked this out. Recording will be live, not live. It is live on YouTube, but it'll be there for posterity. So I'll stop recording. Go from there. Well, cool. Thanks. This is a lot of fun. Appreciate it. Yeah.
Thank you.